If I have 5.6 liters of a gas in a piston at a pressure of 1.5 atm. So when I read that, I realize that the 5.6 liters and the 1.5 atms are together. So it doesn't matter if I put them here or there as long as I put them together. So 1.5 atm times 5.6 liters. ATM being a measure of pressure, it's the STP, right? It's the standard pressure. And 5.6 liters being the volume. Equals. And compress the gas until its volume is 4.8 liters. So the new volume, or V2, is going to be 4.8 liters. What that's going to be multiplied by is P2, or P final, whatever you want to call it. So let's make a prediction. So 5.6 to 4.8 means it went down. Well, if indirectly proportional is the relationship here, we could predict that the pressure should go up. Well, you do your math on it, right? So this is just basic algebra now. You take both sides and you divide it by 4.8 liters. So here, 4.8 liters. Liters cancels liters, leaving you ATMs as your unit. P equals, you do the math. Two standard figures, two standard figures, two standard figures, two standard figures, two standard figures. We're multiplying and dividing. Answer gets two significant figures. Therefore, the answer is 1.8. And the label of, well, it must match. So it's ATMs. Now, does that make sense? Well, we said if our volume went down, our pressure should have gone up. And indeed, it did. On this page, we'll do number 1 now. Number 1's got a little bit of a quirk to it. It says 1.0 liters of a gas at standard temperature and pressure is compressed to 473 milliliters. What is the new pressure? So you're told you have 1.0 liters. That is a measure of volume. So you have a volume that's 1.00 liters, right? And you're also told you have this STP thing going on, right? So we know the temperature is 273.15 Kelvin, and we know that the pressure is equal to 1.00 atms. Why? Because that's what we've measured STP to be. We're also told we have another, volume, so V2, that's going to be equal to 473 milliliters. Well, that's a problem for us, isn't it? Because the units don't match up, liters and milliliters. So what do I have to do? I have to change one or the other. It does not matter which one you do. I think it's easier to make 1 liter 1,000 milliliters. Now all I have to do is link it all up. It wants to know what the P final is, right? The temperature, quite frankly here, guys, is what I would call window dressing. Now, set up your problem. So, 1.00 atms times the volume of 1,000 milliliters equals the pressure final, P2, times the volume when it's 473 milliliters. So in essence, what we've done is we've taken the volume and we've cut it in roughly half. So what should this do? It should double. 3 sig figs, 1 sig fig, but let's look at what we had in the original problem. I gave you 3 significant figures, so let's hold that. 3 significant figures here, let's put 3 in our answer, therefore the answer is 2.11 atms, and it's pressure, right? So I asked you, it should relatively double. Well, 1.00 to 2.11, it does just about double, therefore our answer makes sense.